For a really long time, individuals have imagined what life may be like in other universes because of the James Webb Space Telescope, the most surprising telescope in presence that question would be able finally be examined while noticing the closest star framework to us, Proxima Centauri, which is only 4 light years away. Scientists have seen a few amazing peculiarities from one of the planets in the framework, Proxima B. These characteristics, called fake lights, have confounded the best characters in the space of science. In any case, what do these lights propose? The presence of clever life. Go along with us as we review the James Webb Space Telescope's disturbing disclosure of SETI lights that could make a huge difference. The foremost life that we are at present mindful of is on Earth. Beginning from the beginning of human progression, individuals have addressed whether there is life elsewhere in the universe. To complete such an interstellar chase, American cosmologists Jill Terrer and Tom Pearson sent off the Quest for Extraterrestrial Knowledge (SI) project in 1980 for a definitive objective was to assemble spaceborne radio transmissions. Radio waves can travel farther and are consequently bound to be distinguished by the 42 radio telescopes that make up the unprecedented Allen Telescope cluster in the California lower Locale Mountains. In any case, before a long time back, no self-evident extraterrestrial signs had been found. Following that, the James Webb Space Telescope's effective send-off helped the excursion by empowering the perception of a degree of unnoticeable planets revolving around faraway stars as the biggest telescope in the world, floating around 1 million miles from Earth and prepared with exceptionally touchy instruments. It has the possibility to uncover Goliath revelations. A really long time back, there were no known planets outside our planetary framework. Anyway, from that point forward, more than 4,000 exoplanets have been found, circling various stars as represented by NASA. The universe could contain trillions of exoplanets. The earliest signs of something happening profound in space past our planetary framework may be viewed as extraterrestrial vegetation. The Galileo space test on its course to Jupiter turned its instruments back toward Earth and saw a obvious indicator of the presence of plants. Perceiving the vegetation, red edge, a biosignature, a mix of red and infrared light reflected by plants for model a planet like Earth shrouded in a wild ought to have areas of strength for a effectively recognizable. The JWST will gauge the VRE of faraway Earth-like planets in the livable zone around stars, which could give huge signs of something happening on a more profound level in the exoplanet's environment. When light crosses a planet-star framework, the JWST can remember it as it enters its environment. The missing frequencies would then be seen through spectroscopy as particles and atoms in the environment assimilate explicit frequencies, making a trademark unique mark that the JWST can perceive. This strategy may be utilized to decide the creation of the air and whether life is conceivable. Life could exist on Earth-sized planets with conditions like our own, described by a combination of oxygen, nitrogen, and carbon dioxide. By looking for components that aren't usually present, one could try and identify wise life. For example, chlorofluorocarbons, CFCs, made for use in refrigeration and cleaning items, would almost certainly be discernible to extraterrestrials investigating Earth's environment from a far-off area. If the JWST identifies CFCs in planetary environments, it could demonstrate the presence of life. Anyway, life on exoplanets likely won't look like life on Earth in any capacity here, and they're even normal living things like extremophile species that can get by in conditions where other residing things would pass on, can appear to be outside of this gathering of life frames. For the most part, microorganisms can persevere through outrageous circumstances, for example, temperatures up to 250 degrees Fahrenheit or acidic, conditions with pH levels under 3, since planets like Earth are almost certain to help life than those with outrageous temperatures or acidic circumstances. It may be savvy to begin with those first. Prime competitors could have temperatures that permit fluid water to exist on their surfaces and circle a steady star. Our sun is a yellow type star. These stars are more phenomenal and normally have more limited life expectancies anyway. In our universe, the likelihood of finding planets circling red small stars, which are more normal, cooler, and dimmer than our sun, is higher. This long life expectancy permits the improvement of life. Furthermore, advancement to create complex animals around 40 light a long time from Earth. The TRAPPIST-1 planetary framework will be the subject of the JW's first mission. It circles a calm red small star with 7 Earth-sized rough planets. 3 of these rough planets situated in the alleged tenable zone could have fluid water on their surfaces regardless of its more modest and colder mass. Contrasted with our sun, the TRAPPIST-1 star radiates light like Earth's, making it reasonable for its planets close by circles the most clear and open door to notice it. Lights outside the closed by planetary framework is Proxima Centauri, a red diminutive person star that is 4.25 light, a very long time from the sun. Proxima is a lot dimmer than the sun, so a planet which should be a lot nearer to it than Earth is to the sun to support life and light of fluid water in. Regal 2016 cosmologists found a planet with 1.3 Earth masses in this tenable zone, a Goldilocks-like zone where the light power is great for softening water. Proxima B circles Proxima Centauri anyway. The way that Proxima B is clean locked makes it a possibly airless dead planet, since it circles its red diminutive person star just 4.6 million miles away. This closed circle opens it to solid sunlight-based winds that could strip away its air anyway. Proxima B gets enough light for temperatures and fluid water like those on Earth. Because of its closeness to the star, Proxima B is accepted to be tidally locked, meaning it continuously shows a similar side to the star, like how the moon does comparative with Earth. Proxima Centauri is around 18% the mass of the sun and produces significantly less light than one could expect for a planet so near the star, around 5% of the sun's power. This could appear like a forsaken, fruitless world, yet fluid water could exist on Proxima B if the planet has an air to trap heat, since the complete energy arriving at it from the sun is just 65% of what Earth gets. The planet isn't especially helpful for life. It is possible flawlessly locked, meaning it continually faces a similar bearing close to the star, making a forever hot side and a chilly clouded side with outrageous temperature varieties. The planet additionally gets 4-fold the amount high energy radiation as Earth does, counting X-beams and bright light. Because of its nearness to Proxima Centauri, Proxima B is likewise assaulted with high energy particles during star flares, except if it has a defensive attractive field like Earth's. Circumstances may not be ideal for life. Notwithstanding these cruel conditions, Proxima B could in any case be a more tenable world. Unfortunately, models propose that the climates of clean, locked planets might be inclined to fast debasement because of the freezing out of unpredictable gases on the night side. Our planet's climate can be recharged by volcanic action, and for planets with solid attractive fields, their airs are less inclined to get away. Since we don't realize anything about Proxima B's volcanic action or attractive field strength, we couldn't figure whether the planet has an environment anyway. Since an environment proposes a chance of life, we are anxious to be aware of Proxima B as one. It could have sun-powered chargers covering the day side to create power, to light and warm the night side which would some way or another be excessively cold and dull for residents. The disclosure of Proxima B has set off a competition to decide whether it crosses its star's face as seen from Earth. These travels would permit researchers to decide the planet size and mass, which would help them gauge its thickness and affirm its rough creation, giving data on the materials used to structure those stones during a travel. Starlight could uncover the idea of the planet by going through its air. Anyway, the likelihood that the circle will be adjusted flawlessly so that specialists can notice a travel is, as it were, 1.5% the star's propensity to erupt further. Convolutes matters. Space expert David Kipping of Columbia College says the star's unsound as heavenly intensity makes a rough planet ingest sunshine and RIT it as infrared light. Anyway, rough planets produce a particular kind of infrared radiation from stars like Proxima Centauri. The James Webb Space Telescope, which was explicitly intended to notice infrared light, might actually identify the infrared mark of Proxima B's environment. Proxima B's infrared mark is significant for distinguishing the planet's environment. The infrared capacity of the JWST, which outperforms that of the Hubble Space Telescope, could empower it to identify city lights on the night side of the planet, regardless of whether they are essentially as weak as those right now utilized on Earth. The JWST could recognize fake lighting for however long it is confined to a recurrence band a lot more modest than the star's light. Proxima B's day side might be vigorously covered with sunlight-based chargers, reflecting starlight as Proxima B circles its star continually. The constantly sides are totally different without traces. Temperature contrast between them. The temperature contrast among day and night relies upon whether the planet is made totally of uncovered rock or whether air and water flow heat on the off chance that there is no environment. Proxima Honey Bee's day side and night side temperatures will change more as the day side will emanate all the